Hi, I'm Dr. Joseph Lamb, coming to you from the Personalized Lifestyle Medicine Center by Metagenics in Gig Harbor, Washington. And this is part of our gut health series. This is the third lecture in that series. And specifically today, we're talking about metabolic transformation and a gut restoration program and what we can do in that regard. So what do we mean by metabolic transformation? What's the concept here? Well, the concept is that this is kind of the currently accepted phase for detoxification. Detox has gotten some negative attention. Detox, initially was a term probably most appropriately used for helping people give up their habits. And it is a term that's used for some of the work that the liver does. But it's only some of the work, because we're not just trying to get rid of toxins. We may also be trying to get rid of hormones. We may be doing the work of, the liver's also doing the work of generating glycogen stores and providing us with glucose. The liver is making things like bile acids so that we can have good digestion. There's a lot that goes on. The liver and the pancreas and a number of our organs, kidneys, are involved with this constant metabolic work. So transformation is a nice way of looking at it. In this context today, we're going to be mostly talking, however, about the transformations that we need to do because of the impact in the environment, because of the things that we're exposed to. It's kind of interesting to note that, according to EPA data that was reported on the Environmental Working Group website, 4.7 billion pounds of toxic chemicals were released into our environment back in 2002. These are new compounds. This number has been greatly increasing. And, kind of the take home on this is that, these compounds are persistent. So, what do we mean by toxic? In this regard, I think in this broad regard, they're talking about things that are new to nature. And what we mean by new to nature is that there's something that man's had a synthetic role in, that man has modified a natural compound, created a new chemical structure. When we take a botanical, like what Sertris was doing with resveratrol and trying to find active ingredients there, they chemically modified resveratrol and came up with what are called new chemical entities, new structures that didn't exist in nature. We have a lot of those sorts of compounds. We have a lot of compounds that we've just concentrated, things that in nature would be relatively diffuse, and concentrating them leads to a degree of toxicity in and of itself. The problem has gotten quite dramatic. And, the Environmental Working Group, for example, pointed out that, in cord blood in children, that there are now commonly on the non-placental side, so on the side, not the woman's circulation, but on the circulation from the fetus into the placenta, that there are 20 common compounds typically found at birth already having been contributed to a child. Includes things like flame retardants. It includes Teflon. It includes some of the pesticides. Michael Lerner, speaking for Commonweal, I heard him speak 2 decades ago, and he basically said that the biggest reproductive rights challenge for the 21st century was not going to be about a woman's right to control her body from an abortion point of view. It was going to eventually be a discussion, how could a woman give birth to a child that wasn't intoxicated by her toxic burden? You know, it's interesting to note that a third of a woman's toxic burden is passed on to her child. You know, some of these compounds that, you know, we talk about are things like atrazine, which is a toxin which is sprayed on corn, and the corn's been genetically modified to not be affected by this herbicide. The atrazine works very effectively at killing all the weeds, and it has significant problems in terms of it's a mitochondrial disruptor, and it's also an endocrine disruptor. And there's kind of scary reports about changes in behavior in frogs exposed to atrazine at environmentally relevant levels. But on a broader perspective, one of the things we're coming to see, for example, is the impact as mitochondrial disruptors. You know, there's evidence that, you know, suggests, well, there's not suggests, but there's evidence that atrazine is in high fructose corn syrup. And at the same time that, you know, we've been consuming more and more high fructose corn syrup, we're consuming more and more atrazine. And atrazine affects mitochondrial energy production and creates mitochondrial stress. And that may, you know, it's kind of interesting to see the maps over time of increasing obesity and how in the Midwest and the South, what we kind of call the obese belt overlaps with the corn belt. And, you know, certainly that's not necessarily causal, but there is a correlation, and it makes us worry. And, you know, I think it's, brings up a really important piece that a lot of these compounds, a lot of the things that we've talked about so far are persistent organic pollutants. They hang out with us. They get into our bodies. They like being sequestered in fat. They like the environment in the liver. And if the liver can't metabolize them, they hang there. You know, the other big class that we're seeing more attention to is the heavy metals. And, you know, basically it's been postulated, for example, by, here's the paper. It's been postulated by a number of different people, the role of mercury and cadmium for vascular disease. Mark Houston talks about that, for example, and the role of arsenic in the onset of type 2 diabetes. And there was a paper that demonstrated that the amount of arsenic in the groundwater in various counties in Michigan correlated with the incidence of type 2 diabetes there. And Barbara Corky won the award just a few years back by the Banning Award by the American Diabetes Association for her work showing that stressed beta cells actually develop oxidative stress, so too much iron, or, you know, saccharin, or certain short chain fatty acids, dietary inputs, and other potential compounds, you know, like the mitochondrial disruption from atrazine, for example. These have the potential for causing mitochondrial stress in the pancreas and the beta cells of the pancreas. And the consequence is the hypersecretion of insulin and high insulin levels. Insulin levels not being driven by an excess of calories or an excess of high fructose corn syrup or an excess of triglycerides, but instead being driven by just the metabolic stress that the mitochondria and the beta cells were under, and the consequence that this kind of high insulin level could predispose as one of the components to insulin resistance. And, indeed, Lim and Jacobs, in a classic paper which came out about a decade ago now, demonstrated that whether you were normal weight, overweight, obese, or mildly obese, if your GGT, gamma glutamyl transferase, the blood test which we routinely draw on people, if that blood test was available and was in the bottom half of the normal range, there really wasn't an increasing risk for the development of diabetes, even with the increased weight. But if you were in the upper half of the normal range, or certainly if you were elevated, then the odds ratio, that kind of relative risk of developing diabetes, went up sixfold if you were moderately obese as opposed to normal weight if you were in the top range there. So definitely something for us to think about, definitely something for us to do. So that really raises the question of, how does our body cope with these pieces? What is there that we can do? What makes some sense? How do we get this burden dealt with? And, the first thing to do is, when we want to understand how we can help things along, one of the things we should do is just think about what the body does. So as a general rule, when we ingest something, things get absorbed into us either because we pull them in, we pull them across a barrier because we want them. There's a specific transporter, or they cross the barrier because they diffuse across the barrier. They can just, it's kind of like that classic experiment when we were probably all back in middle school and high school of putting water in on one side of a membrane and then putting like salt water on the other side of the membrane, and the water would pull over and the membrane would move to the side as the water came through the membrane, but the salt couldn't. And what it was trying to do was reach the same concentration on both sides, so it would pull water over so that it would be balanced. So it wouldn't be a highly salt compound on one side versus the other, and you'd see the swelling there. That sort of passive diffusion is how some of these compounds, these organic compounds, get across into our body when we ingest them. Now, some of them get broken down just simply by digestion. That's why certain hormones can't be taken orally as well. Testosterone is an oral hormone, is a large enough structure that it gets broken down. Other compounds like insulin are broken down. We can't give a lot of vaccines that way because they're also broken down. The component, the protein that we want to make the immune response to, we don't make an immune response to because we digest that protein. But certain smaller organic molecules which have the potential for creating effects do get across. They get into our fat and they like staying there. The fat is what we would call, things that like fat are called lipophilic, and things that like water are called hydrophilic or polar, because they're able to have a charge across them, an electric charge, and so they have a pole, a negative and positive pole, a negative and positive end. And that fits well into staying in the water phase. Kind of this example of partitioning, you can see it whenever we look at a salad dressing. And we have a salad dressing, and there is a water phase and there's an oil phase. And you have to shake it really well to get the water into the oil. and certain things like hanging out in the various phases. The spices frequently will end up in the non-oil phase. They'll settle out. And, it's like, how do you get the mix there? Well, in our bodies, persistent organic pollutants are persistent because they hang out in the fat and they prefer to stay in the fat. So in what is classically looked at as type 1 transformation, it is an oxidative step. It's a step where we're putting a charge, the potential for putting a charge on a lipophilic compound. And then the second step is kind of a conjugation step where frequently we're making a salt. And the concept behind making the salt is that what we're attempting to do is to now make it so that it will indeed stay in water and not be reactive. The way I like to look at it, it's a little bit like sticking a Velcro patch, like one half of a patch onto a molecule. It's going to try to rub that patch off and try to leave it other places. And that's kind of the oxidative stress of what happens. Like when we're deliberately oxidizing the compound, that compound has the ability to pass that charge before it gets the second half of the patch attached to another molecule attached to it. Before that happens, it ends up being it passes that patch somewhere else because it doesn't want it. Kind of peels the patch off and puts it on another molecule. So, an example of things that can get oxidized that we wouldn't want to get oxidized would be like our lipids. When we talk about cholesterol, when we talk about LDL cholesterol, we can talk and measure oxidized LDL cholesterol. And so we wouldn't want that to take place. We wouldn't want that oxidative stress taking place kind of in a promiscuous way with cells and compounds of the cells that we want protected. So, and we don't want the mitochondria, getting stressed by the oxidation. Oxidation takes place in the mitochondrial chain to make energy, but if there's an excess of oxidative stress, then you get damage and you get that hypersecretion of the insulin, for example. So, as we look at these pieces, we start saying to ourselves, how do we deal with that two-piece process? So one is making sure that we can soak up oxidative damage, and two is that we make sure that we have the components for phase 2 balanced against the components for phase 1, so that once phase 1 takes place, phase 2 takes place, and now the compound is ready to be excreted in phase 3, which would be out into the liver. Out from the liver into the kidneys or into the urine or out into the stool, so it could be gotten rid of. Compounds, things that we need in nutrients that we use during phase 1. We use nutrients like riboflavin and niacin and peroxidine, vitamin B6 and folic acid and B12 and glutathione and the branched-chain amino acids. During kind of things that protect us against oxidative stress are the antioxidant vitamins like vitamin A and C and E and CoQ10, and then other compounds like the cruciferous vegetables are rich in thiol substances, selenium, copper, zinc, manganese is some of the short chain, some of the trace elements. And then bioflavonoids and silymarin and pycnogenol from grapeseed extract. they play a role. Certain hops compounds can play a role in being antioxidant. And, ultimately a broad spectrum of vegetables, eating rich, which is why the kind of elimination diets that we have people eat include such a component of a richness of vegetables and fruits during this time. Even just a good quality multiple vitamin can make a big difference. We did work back in the day when this was the Functional Medicine Research Center showing that our Phytomulti, our multiple vitamin with a phytonutrient component, that 2 of those a day had an ORAC capacity of, compared, to the peroxal measurement. So compared to, certain foods, it had an ORAC value, 2 of them a day of 5,200 approximately. And that was equivalent to the ORAC of 10 servings of fruits and vegetables, which would be 3,000 to 5,000 a day. We did something called a COMET assay, which demonstrated that it protected cells, human immune cells, against DNA damage that was caused by a stressor like peroxide. So if you added peroxide to a group of human cells in a tube, and these cells were exposed to the peroxide, it caused DNA damage, and you could measure how much it was, and you could actually look at it in terms of, as it spread out on an electrophoretic gel plate, and it almost looked like a comet with the big pieces and then the tail of all the fragmented pieces that had been edited during the repair phase. And if you pre-treat it with the phytonutrient extract, you prevented that damage from taking place. So an important thing to do, just to think about the fact that, a good multiple vitamin could make a difference in that regard if it had the right phytonutrients. And, for example, oxidized LDL was shown to drop from the mid-50s down to the mid-40s with the administration of this. 60 and above is considered elevated, and these were healthy individuals with normal cholesterols, and it made a significant impact. So, this ability to take the right antioxidant and protect yourself. And then, kind of in that phase 2 component, the things that really make a difference, the nutrients that you need are like the vitamin B5 and B12, and you need magnesium and folate and choline, and you need certain catechins. All of these play a role as cofactors. And then, things are bound to glycine or taurine or glutamine or N-acetylcysteine, cysteine and methionine. These are all pieces that you need. And so you end up with the ability to clear things from the body and get rid of them. So programs that would be put into place to help someone who has an identified issue, you start putting into place programs that are going to make a difference. You want to have a program that broadly looks at phase 1, phase 2, contributes to appropriate phase 3, that helps with heavy metal excretion. And so, we have a program that would entail, for example, a 28-day elimination diet. And why do we do our 28-day elimination diet? Well, we do that because of the fact that we know that part of the problem is what we're putting in. And if we reduce those loads, if we reduce the stimulus of caffeine, which is tough from a metabolic perspective, on in terms of energy and rest, if we reduce alcohol intake, which is tough on the liver, if we get rid of we have less of the organic pollutants coming in. We have more ability to deal with the ones we've already got. So we're not getting pesticides, we're not getting external hormones and the such like, we're not getting foods with bad profiles. So, theoretically, we're cleaning up our protein sources so that, we get ones higher in omega-3 fatty acids versus omega-6 fatty acids. We're not getting in heavy metals from eating fish rich in heavy metals, for example. We're not getting in growth hormone. We're changing caloric content and reducing inflammation that way. We're increasing our omega-3 fatty acids. And we're eliminating foods that we could have food sensitivities to, hypersensitivities that lead to an IgG-based food reactivity. And so we take all of these things out so we can do metabolic work. Typically, it's a 4-week process. We have 10-day programs and we have 28-day programs for cleaning. And kind of like, I think of the 10-day program as kind of a spring cleaning, and everyone should do it each year. I think about the 28-day full elimination with later re-challenge for the foods that you're taking out as a diagnostic test if you're concerned about the causes of food allergies. So supplementing with nutrients during this process that help, here in my personal practice, we use a lot of Ultra Clear Renew. We had an excellent paper on that, demonstrating our work. Co-authors were Vera Konda and David Quigg. Vera Konda from Metagenics and David Quigg from Doctor's Data. And we demonstrated, for example, in a group of individuals with fibromyalgia that we increased mercury excretion and we reduced symptoms during a 4-week program, kind of this metabolic transformation program, using the Ultra Clear Renew medical food. Similarly, and I guess it's actually a functional food these days, but similarly, as we put together these programs, they're important because you want adequate protein for you to do the metabolic work. You want to have good, clean, complete protein. So yes, it's non-allergenic because it's pea and rice, but it has branched chain amino acids to make a difference. We sometimes supplement with other botanical formulas like our Metalliclear formula or our Advoclear formula. And we lead through these programs, paying particular attention to how people are feeling, sometimes using vitamin C, sometimes using magnesium. It's important to stay hydrated during a detoxification. It's important to have a daily bowel movement during the detoxification. So we want to make sure that we're doing the right things to make a difference over time. This is an important process of, restoring kind of good metabolic transformation. Similarly, sometimes we're also dealing with a situation in which the toxicity over time contributed to a leaky gut. And, from a gut health perspective, we want to restore integrity because, if it's a simple matter of identifying, for example, that we're gluten sensitive because gliadin, the protein, the specific culprit protein, but we now recognize that it's not as simple as we thought because it can be chemically modified, and some of the gliadin-like compounds are the ones that we actually react to. But when you look at that, if you've got a leaky gut and you take away gluten, which was getting across and you had an immune response to, if you don't heal the leaky gut, you've got the potential there for just other foods that you've now increased in the amount, leaking across and creating an increased piece. So you've got to heal that gut. So, using a product like Ultra GI Replenish which has specific human milk oligosaccharides in them, that human breast milk, that these messages played a role in changing permeability when a child is young. If you pick the right ones, you have the potential for helping heal that gut. Part of the program is, removing toxins, replacing components that are missing, like if you need digestive enzymes, if you need additional stomach acid, replacing nutrients that will help heal, the repair piece in terms of glutamine or precursors to butyrate and the such like, making sure that there's adequate fiber, making sure that you're replacing missing bacteria and kind of the reinoculation phase. And, the repair phase, putting all of these components together to craft a program that will make a difference. That's what functional medicine is, looking at the individual. It's not one program for everybody. It's identifying which program addresses the functional challenges you're having and supporting you through, not treating disease necessarily with a metabolic transformation program, but supporting your body's physiology, the structure and function as you negotiate a path in which you're struggling with illness and disease on your path to optimal wellness. I'm going to be back in about a half an hour with the next in the cardiovascular series. So I look forward to talking to you then. And we will be back. Dr. Michael Stone and I will be back at 4 o'clock this afternoon for our Monday Lunch and Learn. If you missed it, we had the Consilience Partnership had a great 90 minutes of authoring, uncovering certainty and rediscovering soul on Saturday morning. All of these videos now are ending up on our YouTube channel. They're ending up on here on Facebook. So they're archived so that you can see them. We hope you find all of this interesting. We are going to be available in person at Harmony Hill the 11th through the 13th of June for a 3-day functional medicine retreat. And we're going to do a 5-day retreat at Feathered Pipe Ranch in July, the 5th through the 10th. And we're giving away scholarships. So I hope you all will join us. So take care. I've enjoyed this time with you this morning and have a great day.